Your new electric car depends on 17 metals you have probably never heard of. These elements are the hidden ingredients of our modern world. They are inside your smartphone, your computer, the servers that power the internet. Without them, the global economy would slow down. Factories would stop. The transition to green energy would stall. These materials are not famous like gold or oil, yet they hold immense power over our future. They are at the center of a quiet struggle for technological leadership. This struggle will define the 21st century for governments, for companies, and for you. The story starts with a simple fact. One country controls most of the world's supply of these critical elements. The name rare earth elements is misleading. These 17 metals are not actually rare. Some of them are more common in the Earth's crust than copper or lead. You can find deposits all over the world. Australia, United States. The real challenge is not finding them. The challenge is processing them. They are usually mixed together in low concentrations. Separating one element from the others is difficult. Expensive, environmentally damaging, it requires a lot of energy, water, harsh chemicals. This is why production is so concentrated. Think of sugar mixed into a big bag of sand. You know the sugar is in there, but separating it grain by grain is incredibly hard. This is the problem with rare earths. Turning raw ore into pure metal is a multi-step chemical process. This part is called midstream processing. Why do these 17 elements matter so much? The answer is magnets. But these are not the simple magnets you stick on your refrigerator. Rare earth elements are used to create the world's most powerful and efficient permanent magnets. These magnets are essential for any technology that involves converting electricity into motion or motion into electricity. They are small, lightweight, and incredibly strong. This unique combination of properties makes them critical for miniaturization and efficiency. Without them, many of our most advanced devices would be bigger, heavier, and less powerful. Your smartphone is a perfect example. It contains tiny rare earth magnets in its speakers to create sound. They are in the motor that makes your phone vibrate. Your headphones use them to turn electric signals into the music you hear. The same is true for your laptop, your television, and many other consumer electronics. These magnets allow engineers to design compact and powerful products. They are a fundamental building block of the digital age, hidden in plain sight. The impact is even bigger in green technology. An electric vehicle is not just a battery on wheels. It is a complex system of motors and electronics. China's control over the rare earth market is overwhelming. It is not just about mining the raw materials. China dominates every single step of the supply chain. According to Reuters and The Diplomat, China currently mines around 70% of the world's rare earth ores. The real dominance lies in the next stage. Processing. China controls nearly 90% of the global capacity to separate rare earth oxides from ores. This is the critical choke point. This dominance was built by design. Starting in the 1980s, China identified rare earths as a strategic industry. It invested heavily in research. It subsidized production. It developed technical expertise for complex refining. While other countries closed their mines, while they shut processing plants over environmental concerns and high costs, China moved in to fill the void. It accepted environmental trade-offs for market control. The final step is manufacturing high-performance magnets. Refined metals are turned into components for EVs and for wind turbines. China produces over 90% of the world's rare earth permanent magnets. In early 2025, the theoretical risk became a concrete reality. China's Ministry of Commerce announced a new set of export control measures targeting rare earth elements-related technologies. These new rules, which took effect immediately, did not ban exports entirely. Instead, they created a more complex and controlled system. The regulations require Chinese exporters to apply for special licenses to ship certain rare earth materials and the technology used to make high-performance magnets. This move gives the Chinese government direct oversight and control over who gets these critical materials and why. The new rules specifically target the most valuable parts of the rare earth value chain. According to Al Jazeera, the controls focus on technologies for processing and refining certain heavy rare earths like dysprosium terbium. These are the elements most critical for high-performance magnets that operate at high temperatures, such as those in EV motors. The rules also cover manufacturing technology for samarium cobalt neodymium iron boron magnets. By targeting the technology itself, Beijing is trying to prevent other countries from building competing industries. The immediate goal is to protect China's technological leadership and national security interests. The government says the measures safeguard national economic security. The impact of the 2025 export controls was felt almost immediately across the globe. The first and most visible effect was on prices. Even before the rules were fully implemented, the market reacted to the uncertainty. The prices for key elements like dysprosium terbium essential for EV motor magnets saw sharp increases. Market analysts reported price jumps of 20 to 30% in just a few weeks. This volatility makes it incredibly difficult for manufacturers to plan their costs. A sudden price spike can erase the profit margin on a car or make a wind farm project uneconomical. Beyond prices, the new licensing system began to disrupt physical supply chains. Some shipments of rare earth magnets were delayed at Chinese ports. Exporters were navigating the new paperwork, and government officials were reviewing license applications. Several European automotive parts suppliers told Reuters they were experiencing slower than usual deliveries. A few smaller electronics firms said suppliers couldn't confirm shipment dates for the next quarter. This forced some assembly lines to slow down production schedules. The licensing system also showed signs of being used selectively. The world is not powerless in the face of this challenge. There are clear, concrete steps countries and companies can take to reduce dependency on a single source for rare earths. Build new, diverse supply chains. Invest in mining. Build processing facilities outside China, Australia, Canada, United States, Mountain Pass Mine in California, Lynas Rare Earths in Australia. Not to replace China, but to create reliable alternative supply. Recycling offers a powerful, sustainable solution. Millions of tons of e-waste are generated each year. Smartphones, laptops, other devices containing rare earths. Advanced recycling tech creates an urban mine. It reduces the need for new mining and environmental damage. It creates a secure domestic source, circular economy, economically and environmentally smart. Modern defense systems are filled with rare earth elements. They are used in the guidance systems of missiles, allowing for incredible precision. They are in the sonar systems on submarines and the radar systems on fighter jets. And secure communication devices all rely on the special properties of these materials. For defense planners, this is not just an economic issue. It is a matter of strategic vulnerability. The 2025 controls are a reminder that access to critical materials is not guaranteed. This is pushing companies and governments to urgently seek alternatives. Diversification, recycling, research, stockpiling. These 4 strategies offer a comprehensive path to a more secure future. They are the secret spice of our high-tech world. Yeah.